better for you to breathe. So it warms it up. Okay. Any questions on this slide? Okay, so the ethmoid bone articulates with 2 cranials and 11 facial bones. Okay, those were the cranials. Okay. Now let's talk about the sutures. Are you guys all familiar with sutures? Okay, so the sutures is, when we're talking about the skull, the sutures are the articulation or the joints of the different cranial plates and other cranial bones. So the coronal, which goes across, okay, is the suture between your frontal and both parietals. Your lambdoidal, one on the back side now, lambdoidal suture is the joint between your occipital and both parietals. Squamosal, parietal and temporal, sagittal, going down the middle. Okay, articulates for both parietals. And then where the sutures meet, okay, these are your junction points. You have your asterions. Okay, way back here, you have a right and a left, and that's where your squamosal and lambdoidals join. The bregma is going to be in the front, right here and right here. That is your anterior sagittals, where they meet. Lambda, all the way in the back now. Can't see it there. Okay. For your posterior sagittals, and then your tyrions, which is your parietal, temporal, and greater wings. You have 2, a right and a left. We good on this?
Mm-hmm.
Now, when you're an infant, these points of intersection, they're still soft. So we know about the we know about the fontanelles, right? The soft spots. So they're covered by membrane. The bones haven't fully developed or grown yet, so they are still open and they are very tender. There are 6 fontanelles in total, and as they grow, they are going to form those junction points. The anterior and the posterior fontanelles, so you have a anterior and posterior. Those will join to form the bregma and the lambda. I don't think this is in your slides.
Just the bregma and lambda.
Okay, so right there, so write down bregma and lambda. So the anterior and posterior fontanelles join to form the bregma and the lambda. The right and left sphenoids, are going to join to form the right and left tyrions.
What is it?
Asterions over here. And then the mastoids back here, they're going to join to form the right and left asterions. Okay, everybody got it?
Hold on, 1 second.
Tony, do me a favor. Can you just close the blinds slightly? Because I'm glaring every time I look at you guys back there. That's cool. Thank you. All right, so here we have PA Caldwell projection. And when we're taking a skull front to back, we usually do it in a PA, meaning that the face is closer to the image receptor. Okay, and there's a reason for that. I'll tell you guys that in a minute. But the most common view that we do for a PA skull is with an angle of the X-ray tube. This is your Caldwell projection. So in a properly positioned PA Caldwell, remember those petrous ridges that we were talking about coming from the temporal bone? Remember that thick mass going across? where it houses your organ of hearing in equilibrium. This is it right here. So for a properly positioned PA Caldwell, these petrous ridges should be right at the lower third of the orbit. You guys see that? So if you break up your orbit into 3 different sections, 1, 2, 3. 1, 2, 3. Okay? These ridges should fill up the lower thirds for a properly positioned Caldwell. Is this properly positioned?
No.
Okay. So again, it should sit a little bit higher this way. Okay? But this is just for the sake of demonstration. All right. So to identify the anatomy, here we have the crystal gale. It looks like a flame projecting upwards. Okay? So this is your crystal gale. Then we have the SOM, which is right here. It's the ridge of your orbit, right below your superciliary, which is right about here. Okay? And then right above that is going to be your groove, right around there. Okay, let me see. Crystal gale, sagittal suture. This is your sagittal suture that comes down this way. You guys see that? Is the sagittal suture found in the frontal bone?
No.
Is there a suture that goes down the frontal bone?
No.
Okay, so where's the sagittal suture coming from?
Posterior.
Posteriorly, right? So again, we're looking at a suture that is in the back of your head. But again, everything becomes superimposed in x-rays. So we're 3-dimensional, but our image is 2-dimensional. So you will see a lot of this superimposition. So when you see this line coming down, that's not your frontal bone, that's your occipital. You have your 2 parietals, okay, because this is going to separate your right and left parietal, right? And then right about here is going to be what?
The coronal.
This is going to be where your occipital is.
So they use like a cotted angle to get that?
Yes. So everything looks a little bit distorted because we have an angulation of the x-ray tube. Okay, D is your lambdoidal suture. Again, that's on the posterior side. So, okay, sagittal, lambdoidal, occipital should be right about there on the other side. And then your petrous ridges of your temporal bone going across. It's a very dense mass of bone. All right. Perpendicular plate is going to be this right here. Remember your ethmoid bone? Kind of looks like a little bat. That's your perpendicular plate. Got it? All right. Let's keep on going here. This is known as an AP axial projection, or the Townes view.
Towns?
Town, T-O-W-N-E, Townes view. And then right in the back of the skull, you guys see this density right here. This is what forms the foramen magnum. And then you're going to see a little piece of bone right there. So I'm just putting that there for you right now. Now I'm going to erase it, so use your x-ray vision. You guys see the hole? You guys see that little bone right there? Okay, that's the dorsum sali. Where's the dorsum sali? What part of the bone is the dorsum sali?
The sphenoid.
It's part of the sphenoid. Okay, so that dense bone, when doing this projection correctly, should set right in the middle of that foramen magnum. Okay? This particular projection looks at the back of your skull. So what bone is this right here?
Occipital?
Occipital. Does it look a little bit funny? Does this look like a skull, or does it look like alien?
Looks alien.
Looks like
You
an
can see the
alien.
orbit.
Because when we do this projection,
Been
it's a
pushed
very
down.
steep angulation, so we can visualize and open up or expand the occipital bone. So here's the suture right there, and there's your occipital. You guys see that? Okay. So it's a very exaggerated angulation, so it does look like the alien, so everything does become elongated, but that is on purpose. How should air look like
Black.
radiographically? These are black, right?
Mhm.
Back of the skull. So what do you think that is?
Here,
Foramens or
What's back here?
here.
Not the ear. Okay, back here. It's part of your occipital bone. Remember the mastoid portion where it contains the mastoid air cells? So this is your mastoids right here, which contains the mastoid and contains the mastoid air cells. So air is black. Okay?
What was the bone that goes in B?
I thought that was the temporal bone,
What did I say?
occipital.
Oh, I'm sorry, mastoids of temporals. Sorry. Yes. What was that?
What's the bone that's in B that you erased?
that's a
Oh,
saddle.
right here?
Yeah.
Dorsum sali. Projected within the foramen magnum. All right. Are we good?
Yeah.
Okay. Ooh. That's a lot of parts, right? That's a lot of parts. Now you know why they spent an entire semester on this, right? And I've only got, what, another 15 minutes to talk? Just kidding. All right. What's this area right here?
The sinus.
Remember that saddle? This is your sella turcica. So what should we find in that sella turcica?
Pituitary gland.
Okay. All right, so let's start from the very beginning. A. A is referring to, and it's hard to see this on here, but you actually can see the external auditory meatus. It's going to look like a little black hole right about there. But again, the radiograph that they put on here, you can barely see the opening. Can you see it now? Right there? Okay, so that's your external auditory meatus. Okay, that's your outer ear. Then we have the mastoid portion here, okay, of the temporal bone. We have the occipital. Okay, so if this is the saddle is formed by what? Okay, so this is the anterior clinoid, right?
Right.
And then this is going to be the posterior clinoid process, right? So now we have a saddle, and right in the back of the saddle is what?
The dorsum sali.
Dorsum sali, okay? And right below the dorsum sali, where the pons sits, is clivus. Clivus, right there.
Cletus.
Yes?
Sure.
Isn't that what it says? So
Yeah,
E
it does,
is
yeah.
clivus, yeah, clivus. Anterior, posterior, the back of the saddle is the dorsum, which is F, and then right below the dorsum is the clivus, where the pons sits. So we know this very well now, right? That area.
Yeah, we know
Yeah,
it so
I'm ready to operate, Doc.
Okay, so we did that. I, very top of your head, that's known as the vertex. The vertex of your skull. So the very top of your head is the vertex. J is pointing to a bone or a suture. As I see a suture coming down
Suture.
this way. So is it suture?
Coronal.
Okay, so the suture that divides the front
And the parietals.
and your parietals is what?
Coronal.
So your coronals. Okay, coronal suture. Okay. What's K?
Frontal bone.
Frontal bone, everybody agree?
Yeah.
L, orbital plates of the frontal. M is the cribriform plate. Remember that cribriform plate? What is the whole purpose of this bone right here?
Nasal.
Oh, it separates the
Separates this
facial from the cranial.
this. So separates the cranial from the
Facial.
bones. So that's your cribriform plate. What bone will you find the cribriform plate?
ethmoid.
Ethmoid bone. Okay, so that was M. N, we already said that was the cella turcica, and then O, orbital what? Oh,
Body.
body of the sphenoid, where you find the sphenoid sinus. Okay, so right below the cella turcica is the body of the sphenoid. We went through that, and you guys were calling out the names. Oh, is it because you're reading it out here, or did you actually know it?
No, we knew it.
You knew it, right?
Yeah.
I don't know.
Yeah, you guys were just yelling it out.
We'll test after this.
Please.
Okay, so I want to spend a little bit of time here on the anatomy of the organs of hearing and equilibrium. So this will be on the, what bone is this?
The temporal bone?
Temporal bone, right?
Yep.
All right, here's your temporal bone. First of all, let's talk about
Bless you.
bony anatomy. What bone, okay, this is your temporal, but what portion of the bone, of the temporal bone is this called? Remember the thick mass that goes across the air, the orbits?
Petros?
The petros, yeah, so these are your, this is your petros,
Bridge.
petros portion, okay? And the very top of that is the very thick edge, and that's called the petrous ridges.
The apex.
Okay, or the apex. All right, so again, in the temporal bone, in the petrous portion is where you're gonna find the organs of hearing and equilibrium. So, outside of the ear, external auditory meatus, this is one of the landmarks that we use in positioning for the skull. It is part bone, part cartilage, so it's not completely cartilage or bone, it's half and half. And the EAM stops right where this tympanic membrane is, and that is also known as the eardrum. You guys remember back in taking anatomy and physiology that this eardrum acts as it receives sound and it starts to vibrate, right? So the vibration then is sent to the three different parts of the hearing mechanism, which includes, what is it, the hammer, the stapes, and then the stirrups, yes. Okay, all right. Let me just, okay. All right. So here are the auditory ossicles are located, and here's your external, this is your internal, and there is a communication within this tympanic cavity where you're going to find the auditory ossicles. This membrane right here, I'm sorry, this cavity right here, there is a communication between the inner ear that goes all the way down to your nasopharynx. This is known, bless you, as the eustachian tube. The eustachian tube communicates between your ear and your
Throat.
your nasopharynx. So the whole purpose, bless you, of that tube is to equalize pressure between the outside atmosphere and the middle ear. That's your eustachian tube. Now, I think we mentioned this before. If you do have kids and they get sick, all the germs makes its way up this tube, and now they get
Ear
an
infection.
ear infection. That's why kids, when they get sick, they're constantly pulling on their ear because it hurts. So the infection can make its way up into the inner ear. You guys remember that?
Mm-hmm.
Okay. Okie dokie. We got this. Okay. So here's your temporal bone, back of your head, mastoid air cells. There's also going to be a communication between your mastoid air cells, or the mastoid portion of your temporal bone, which is right here. It's called the recess or the attic. So now you also have a communication between your mastoids, air cells, and also your eustachian tube. And so when you get sick, you also can feel pressure in the back of your head. So that's where the infection can go. So especially if you have an infection in this area, it's called mastoiditis. And you have increased pressure in the back of your head, and it can also screw up your equilibrium. Okay, questions here? hammer, anvil, stirrup. Okay, we're going inner. Let's just keep going over here. Okay, so once it goes through the auditory area, that's gonna the signal is gonna go into the bony labyrinth, and this is what's gonna house the membranous labyrinth, divided into two different parts. In one part, you have your semicircular canals, and they are identified by their location. So you have your superior semicircular canal, you have your lateral, and then you have your posterior circular canal. In this area, the semicirculars, bless you, semicirculars are responsible for equilibrium in direction. Okay, and then on the cochlear side, this area right here is responsible for hearing. Okay? Okay, so semicirculars are responsible for direction and balance, and then the cochlear area is for hearing. All right, we done with the anatomy part of it?
Oh, okay.
Okay. Yeah, okay. Skull morphology and topography. Skull morphology talks about, is referencing the size and shape of the head. The average skull is called mesocephalic, and the average shape of the skull is like this. So your average width is around 15 centimeters, and that's from one parietal eminence. Okay, an eminence is of the parietals is the bony projection on each side, and we measure from eminence to eminence, and the average length or width is 15 centimeters. Then there is also a measurement from your frontal eminence to the occipital protuberance, and that averages about 19 centimeters. The width in general is going to be, the width is going to be about 79% of the length. And this is on your average size skull, mesocephalic. Now I did change this up a little bit because your book was the slide that you had up there was very deceiving. Mesocephalic is your average size, yes? Okay. So the width is between 75 to 80% of the length. Brachiocephalic is your fat head. Okay? So that's going to be greater than 47%. Okay, this is me, I think I'm a fat head. So the width is going to be 80% of more than the length. And then your dolichocephalic, I think in the slides it looked the same as the mesocephalic. Didn't it look exactly the same? In the slides that you have?
Kind of, yeah.
It did, right? So yeah, so that's why I put this picture up here, because this is a little bit more obvious. So dolichocephalic is more narrow than the average size head, and the width is less than 75% of the given length. Okay? So meso is average, brachio is big, dolicho is going to be narrow. Okay? Any questions? So when they're comparing the angle here is the average angle between your mid-sagittal plane and your petrous ridges is an average about 47 degrees. With a more wider head from your mid-sagittal plane to your petrous ridges is going to be greater than 47 degrees. Okay? And then mid-sagittal plane to your petrous ridges on the dolicho is going to be less than 47 degrees. So it's comparing those two structures. It's your mid-sagittal plane and your petrous ridges. Okay? So we're not only comparing width and length, but also comparing the angle compared to the mid-sagittal plane and the petrous ridges. Okay, any questions? All right, facial landmarks. You have to know your facial landmarks. There's a lot of them. Okay, we know what MSP is, right?
Mm-hmm.
We know what glabella is. Oh, was that already up there?
Yes.
Bullseye.
is a bullseye.
That is a bullseye. So glabella, okay, is that area between your eyes where the bridge of your nose meets. The nasion is the bridge of your nose. So where the bridge ends, the nasion is your bridge. Then you have your IPLs, or your interpupillary lines, which is the one point to the next point. These 2 points are called your outer canthus. This is known as your outer canthus, the edge of your eye. So you have your outer canthus, you have your inner canthus. So the interpupillaries is from one outer canthus to the next outer canthus. The acanthion is where your upper lip meets the bottom of your nose. So this is your acanthion right there. So it's where your upper lip meets the bottom of your nose. The angle, what they're referring to here, the gonion, is the angle of your mandible. So this is your gonion, the angle of your mandible. Mental point. What's another word for mental point? Chin. That's your chin. Supraorbital groove. Again, that's an indentation as you run your fingers through right above your, what is that called? Your superciliary ridge. So it's right above that. Some more landmarks. So we got glabella. We already talked about the glabella, nasion, acanthion. Lip meets the nose. Chin, angle of the mandible. Tragus is just basically the cartilage right off of your EAM. This is it even on here? So what is this area called right there? I just said it.
Tragus.
No, that's your EAM. The hole in your head. That's your hole in your head right here. This is your tragus right here. It's that cartilage. Okay. The auricle is your, I don't know, your ear, outer ear, and then top of ear attachment, also known as a TEA. So far, so good. All right. So here we have our outer canthus, inner canthus. Supraorbital margin, inferior orbital margin, so the top of your orbit versus the bottom of your orbit, and then mid-lateral orbital margin. Again, we're talking about the outer ridges of the orbit. All right.
Oh my God.
In positioning the skull, we make references to all these different imaginary baselines. These are called baselines. Okay, write these down somewhere. They're called baselines. All right. So one of the baselines that we use is the glabellomeatal. Meatal referring to the meatus of the external auditory meatus. So GML is glabellomeatal line. The most common imaginary line that we use is the orbitomeatal line, and that goes from your outer canthus and this imaginary line to the external auditory meatus. So this is one of the most common lines that we use is the OML. Okay. Then below that is the infraorbital meatal line. This is also known as the Reed's baseline. Also known as the Reed's. So when we say Reed's baseline, it's the infraorbital meatal line. It should have been called Trigonez's line. All right. AML, what does that stand for?
Acanthomeatal.
Okay, acanthal. What is acanthal?
Yeah.
The acanthus, okay, and where's that found?
From your upper lip.
Bottom of the nose and top of your lip, okay? We also have a lips meatal line, LML, and then MML is your chin, mental meatal line, MML. The glabello-alveolar line is this imaginary line from your glabella to the alveolar bone, okay, of your mandible. So it's basically from chin to forehead. All right. Positioning aids that you can use to make sure that you have proper positioning in the skull. You can use either a straight edge, or they do have angular rulers that you can also use to make sure that you are using proper you're using your proper baselines and positioning. Okay. Positioning in technical considerations. Erect versus